So let's go ahead and run that and go back to our workload group. So you can assign for loading purposes, for query purposes, and various ad hoc systems. You can give a percentage, as we said, of the resources on a SQL pool, which is the cluster, the distributed cluster. We can give 50%, etc. So you can see that we can give a cap the resource usage and set resource usage using workload groups. So we've set that. So now let's go ahead and run a very heavy query again. Our queries here. So we're going to kick off the trigger to see what happens. And we're going to go ahead and kick it off. And it's running. As it's running, let's go ahead and take a look at. We already ran this. There was nothing running before. So let's go ahead and take a look at what is running right now. And we should be able to see that, there we go. As it's running, you can see that there are certain queries that are running that are below normal importance, right? And they are all below normal importance because they are all assigned to the workload O2 group. That's the key thing to understand here. As we set different workload groups and classifiers, we can actually give it high importance. We can give certain level of system resources so basically splicing up the cluster using workload groups gives us the ability to do this across the board. And you will see it in action if you run. Basically, you can go in and run your DMVs or go to the Manage Monitor tab and just look at the SQL requests, and you can see it from here also. So you'll see that whatever queries that I've running, right, and I have some of them that are completed and some of them that are suspended and others that you can check which ones are running by just simply clicking on the status from this monitoring side. So it's a great way to kind of understand how to set up workload management across the board. So as you can see, workload management gives us a lot of flexibility on setting up the splicing up the cluster, the SQL group as we need. So on the SQL group, what we're going to do is we're going to adjust our existing classifier, and we are going to set up we're going to adjust the amount of resources so that we can actually have more queries running at the same time. To do that, we just need to simply adjust the resource class, and this is what we're going to do right now. So let's go ahead and adjust this resource class and run the queries again. So we have adjusted it to take only 3.25 minimum resources per request. And when we run our heavy flood queries again here. Now let's go ahead and trigger it. You can see it's going ahead and running tons of queries right now in a loop. And we can see it actually running. So let's go ahead and take a look. There we go. We have a number of queries that are running across the board and others that are queued up below, so that you can actually see they're still below importance, and they have basically a specific set of rules of how to actually using the workload resource class. So this gives us a lot of flexibility in what we can do. Being able to run hundreds of queries on the same cluster at the same time, that gives us a level of flexibility across the board on the Azure Synapse SQL pool. Great, awesome. All right. As we bring in data, we want to be able to optimize the data warehouse for query performance. That's actually a very important thing for many of our ad hoc queries, for our reporting applications, etc. So how do we manage that? How do we optimize query performance in the SQL pools? Let's take a look at that. And when we are talking about data that lands in our SQL pool, they can land in multiple types of tables that you can specify. So when we're landing it, by default, there's a concept called distributions. The distribution is a basic unit of storage and processing for parallel queries to run on distributed data. So when Synapse runs a query, it is able to divide it